I wanted to sort of welcome you to the session, and the way we're going to handle the session is I've got 4 excellent speakers that will be providing presentations related to the industrial Internet of Things and all of the topics that surround them, from connected enterprise concepts, cybersecurity concepts that relate to small and medium-sized manufacturing companies and Industry 4.0 and how that rolls out, and then also talent, tech, and capital. And so the way I think we'll run the session is that the speakers are from Rockwell, from Eaton, from Magnet, and from MCPC. And we'll go in that order with Raj first, and then Michael, and then Brandon, and then Michael. And each will have somewhere around 20 minutes. And so if you see me waving or doing something like that, it means that you're probably getting close to the end of time. What I'd like to do, though, is to hold all the questions till the end, and then we'll have a Q&A session based on the time that remains in the session. So without further ado, I'd like to introduce Raj from Rockwell Automation.
Thanks for the opportunity to come talk to you people. I don't know how many of you have done this before. I've never given a talk less than an hour. So 20 minutes is going to be challenging. So Ken is dangerous with a chalk. I'm dangerous just anywhere. So I'm going to hope that some of you will wave your arms and say, my time is up. It's time boxed and organized in such a way where I can stop wherever I want. And so just feel free to stop me, Michael, particularly, especially if you want some time. I've been with Rockwell for a while. And today I'm here to talk to you about digital transformation, and our tagline is bringing the connected enterprise to life, and that's what we're going to talk about. So let me give you a Cliff Notes version of it before I launch into the slides I'm not going to get through. If you have seen Professor Yu's paper, Figure 2 describes everything that I need to talk about here. So that's all you need to know. The second thing I'll tell you, and I was telling some people earlier on, is that we don't use analog computers in our controls. It's always digital. So we've been a digital system forever. So digital transformation is kind of a funny thing when it is always digital. But we are still going to talk about how things have changed even in that world. So that's what I'm going to focus about. Okay, a quick level set for everybody. Rockwell Automation is a $6.7 billion company. We have 23,000 employees, and I think we operate out of 80 plus countries. The most important thing is the tagline that you see at the top. That's how we are living and transforming our business. And if time permits, we'll get to how we are using this in our own businesses, in how we transform ourselves with the kind of things that we sell to our customers as well. The second thing I'll tell you is that we are a big presence in Cleveland, which is where our control and information business is. And we do a lot of product development here. And I come from the system architecture team that sets both the business and technology strategy for our product life cycles. And we work very closely with Case Western, and we are really proud of our engagement and partnership with them. Okay. A little bit more about us as a company. We've been in the top 100 inventors on the Forbes list for quite a while. They measure it by the number of patents that are received and how those patents make it into the products. We are also being voted, we're very proud of this, that we are a highly ethical company, and sustainability is very important to us as well. Okay, so bringing connected enterprise to life. That's our tagline. So what we mean by that is what I started out with, that we've been a digital system forever. That's not the problem. The problem is that over the years, we have seen how these things start interacting with each other and how data flows where the decisions can get made. And the decisions can get made at every level of the factory, not just at the top level where the strategy is set and the product deployments for production are deployed. Okay, that's the transformation. The second thing is that once you connect it, it's not just about technology. It's about understanding how a production plant works, what you're trying to do with it, and how to get the right data to the right place. Okay? In looking at this, we take a customer-centric view. What does this mean to the customer? Because we already have the products, now we need to tie them together to bring value to the customer. So we try to do that in these 4 pillars, as we call it. Faster time to market, operational productivity. Faster time to market is how can I allow our customers, whether you're making a toothpaste or an automobile, to get it to market as soon as you can. So we help them in the design side of it. We optimize changeovers and take the design and make it flow through into manufacturing and production and shipping. Okay. The second part of it is how do we allow them to more efficiently operate their machines and their factory and their lines and their production facilities and all that. So that's the second place where we try to help them. The third is in improving the asset management and reliability. So you can have the best design and the best manufacturing process, things happen. Products fail, machines fail, and how quickly are we allowing people to repair and put it back in production, and how quickly are we able to diagnose it so we can even prevent it from before it becomes damaged. These are the areas where we are seeing a lot of changes in our strategy in bringing the connected enterprise to life. I'm going to defer the 4th topic to Michael. He's going to talk about cybersecurity. It's a big part of it, of where you have a lot of digital devices that get networked, and you know there are going to be issues with it. And that is a big issue of not only protecting it and making sure there are no vulnerabilities, also to preserve your performance while you're doing it. So product development and things are not getting any slower, so people want to build faster products. As an anecdote, I started out as a CNC computer numerical control architect, and at that time our course interpolation rates used to be 20 to 30 milliseconds per course iteration. You don't need to know what that is, just know that every 20 milliseconds or 25 milliseconds we need to drive the next place to be. Okay, now it is down to a quarter millisecond. Okay, so what that means is that you're able to build products faster, build it with more accuracy, and have a better performance in how smooth it is or how quick you're able to get it out of there. So you can see that those 2 things, the need to speed things up and need to secure it, are kind of at odds. Okay, so that's where the 4th pillar of reducing the enterprise risk and securing all these operations while you speed things up comes up. Okay, I'm not going to spend too much time on this. This is really to present to you how a company can benefit, our customers. How can they benefit by adopting a digital transformation strategy that works for them? Okay, this is an overloaded term, as you already know. When you say digital transformation, people think of all kinds of things. Okay, and what I'm trying to attempt is to tell you kind of how we view things in the value we bring to customers. Okay, and how we use digitization, networking, and security in order to speed up their time to market and make it more efficient and safe for them to operate. Okay. So I'm going to skip over this one as well. So let's stop here. This is where we'll spend a remaining time that I have on. Okay. Earlier I talked about how things have always been digitized. Okay. The difference is really the scalability of it. So on the y-axis, we have things that go from the enterprise to system to device. Okay, meaning from a factory, you can make your MES plan, send down a production schedule down, and at the system level, you have a line or a work cell that is producing things, and down at the device level, you have I/O devices and controllers and drives and things like that that operate. Okay, on the x-axis are different levels of intelligence, if you will. Okay, so in the descriptive, diagnostic, predictive, and prescriptive. The descriptive part of it is to say, to pick an example, hey, am I running okay? Did something go bad? Okay. The diagnostic part of it is, why did something happen? What was the fault? Okay. The predictive side of it is to be able to tell people that something is going to happen. Okay. And the prescriptive part of it is to say, hey, something might happen, now go out there and fix it. So when you look at a digital transformation, you can see that these kind of decisions have value at every level of the X and Y axis dimensions. Okay. The thing that changed out in the digitization world is what IoT brings to us. To me, IoT means you are pushing intelligence down to the lowest compute element possible. Doesn't mean all the decisions need to get made there, but you need to look at the decisions you need to make and scale them to make them at appropriate level. The thing that has changed for us is what happens with compute elements. Now, earlier I presented a dire picture saying we went from 20 milliseconds to a quarter milliseconds. But computing and networking have advanced to such a level where that is possible. When that becomes possible, now you have the compute memory and speed to put in small form factors where you can do a lot more than we used to do, even 2 years ago, 5 years ago, or 10 years ago. Okay, so that means that we are able to take those decisions and have enough of a compute surface at every level. You would not think of a photo eye making a determination that it needs to be replaced because the shield is getting occluded and not picking up the parts that are going through in a predictive manner. But we can now. We didn't used to. Those kind of decisions have to be left to humans in the past. I'm not an anti-automation guy, okay, because I represent automation. But the decision making and productivity improves when you have machines do more or support more decisions. Okay, so when we say scalable analytics, this is the one I was referring to Dr. Yu's paper. It is really about how you do any kind of decision making. We picked analytics as an example. There is a lot of machine intelligence that we apply to these things, and a lot of data analytics. It is not practical to send all the data out to the cloud, make the decisions there, and push it down to the end nodes where the actuation has to happen to act on the decision, which is why we believe in distributed intelligence and distributed decision making. So I touched on this earlier, that it is not just about technology. Okay, you have to bring all three components together. You have to bring together the people, the processes, and the technology to match up with solving problems. So to give an example, a maintenance person may know better that when you see a vibration in a bearing, it goes bad in two production cycles or 3 shifts. They know that. A computer is never going to know that. So how do you take that and then marry that into technology to say, okay, there is a vibration sensor, and I'm going to send an algorithm that incorporates this knowledge into it, and then use that to make the decision of how you do maintenance. That's what we mean by bringing people, processes, and technologies together to solve problems. Okay, and it is not a one-off kind of thing. You have a graduated way of advancing your organization. You don't have to go greenfield to get all these benefits. You can start at the layer that makes sense and improve it. And we really truly believe in continuous improvement, whether it's in processes or in how we do sustainability within our company, how we do product development. We do not try to solve all the problems at one shot. Okay, so the customers also can take the solutions that we are giving and deploy them in a graduated manner in getting them to the outcomes in a step-by-step basis. Okay, so who are we? This I found amazing when I started looking at it. There is a reason I'm telling you this story now, not just to brag about what we do. We have 387,000 SKUs when we did it. It is almost unbelievable that in an industrial automation company we'll have that many products to sell, but we do. We operate out of 20 plants, and about 200 SKUs are made to order. What that means is when we start the production, we don't know what we are going to make. We look at the incoming order to say, you need to assemble this part this way. So that's 200 of that 387,000. That looks like a small part of our portfolio, but some of these are probably, I would say, as big as 4 or 5 refrigerators put together. The drive systems are built like that. And those things are really large parts that get built that way. And the thing is that our stocking systems also keep track of inventory and tell us what to build as well. Okay. The reason I told you this story is that we apply all the principles that we tell you in how we operate our own facilities. So we are not just a company that produces industrial automation, we are a manufacturing company ourselves. So it's in a dog eat the dog food kind of way. I think somebody was telling me earlier that they live in Hudson and drive by our plant. Is that where I work? No, that's not where I work. I work in Mayfield Heights. But that plant in Twinsburg applies all our products and practices, and we use that to showcase it to our customers to show how we solve the problem with our own products. Okay? So everything that I talked to you about today is not about how we wish we could do things. It is what we are doing now in our products and how we are applying it in our own manufacturing facilities. Let me talk a little bit about this partnership that we have with PTC. I don't know how many of you know about PTC. It's a Boston-based company. So we look at it as information technology, operations technology, and something in between. So this is where the digital transformation part of it comes along too. So PTC, our partner, is very focused on the in IT or information technology side of it, and they are the ones that work with manufacturing partners and come up with product scheduling, product design, and how to look at data in the cloud and figure out analytics from that. So that is their strength. Our strength is in moving machines and sensing the movement and collecting data from it, which is on the operations technology side of it. And in between, the thing that we kind of glossed over, both companies do it. They have some products that kind of get to the edge of their operations side of the networking and peeks into it. We get more into the IT side and peek into it. The critical thing in the middle are the gateway products that we do a transformation between IT and OT. Okay, so the protocols that we use on the networking side, even though it is on Ethernet, is different than the protocols that we would use on the IT side, and we need to form the bridge of data between the two of them. The speeds are different. The amount of data that is collected is different. So think about it this way. If we were to look at that photo eye sensor that I talked about, and you collect every sample of it, maybe every 10 milliseconds, 20 milliseconds, can you imagine, even if it is just one byte of data that you collect, how much data will flow through? It is impractical to think that you can take all that data and put it up somewhere, make decisions, and bring it back in real time to control something. So I report through to Sujit, who's our CTO, and he normally gives this example about the things that happen at the OT level versus IT level. So if you are driving a car, and say a Tesla, and there is data that is coming out of the car, would you wait for it to go to the Tesla service and come back and tell you there is an obstruction in front of you? You would never do that, right? So there is a role for decision making at both the OT level and the IT level, and our partnership with PTC is really to do that leverage. So as part of that partnership, we've come out with, we had a Factory Talk suite of products, which is our MES and software products. At the very right end of it, you see that it is a Factory Talk Innovation Suite, and parts of it is how you get data from the OT layer, and how do you transform it in a way that is useful in the IT layer, and use those things in order to help people make decisions. Okay, they have this product portfolio called Vuforia, which is an AR/VR technology, and we have found use cases that marry these things together. And I know we do some work with that with Case Western as well. We marry these things together in order to present to decision makers on the plant floor with augmented reality decisions. Okay, so we do some work with them on the planning side of it, on the analytics side of it, as well as on the augmented reality and virtual reality side of it. There are a few more slides, but I think I'm running up on the time, so I'm going to stop and ask Michael to take over and talk about all the other problems that come up with cybersecurity from all the things I talked about.
Thanks, Raj.
It's not that we don't solve the problems, but we would like to hear Michael talk about it.
Good morning, and thanks, Raj, and really happy to be here today. So my name is Michael Rogelski, and I am Chief Technology Officer for Eaton's electrical sector. And interesting, the name of this session is Digital Enablers. And when I'm going to talk about cybersecurity and the industrial Internet of Things, I don't know if it's an enabler, but it's absolutely a derailer if you don't get it right. So a little bit about Eaton. We are known as a power management company. So we produce products and systems that manage electrical, mechanical, and fluid power. We're over 100 years old, and we're about $20 billion, and we operate in over 700 locations around the world, and we have about 100,000 employees. So we've been around for a while. Our brand promise is we make what matters work. So we're not a consumer-facing brand, but when you do your e-commerce transaction, or you think about the lights that are powering this conference and the heat in this building, our products and systems are hard at work behind the scenes, making sure that electrical power is delivered safely and efficiently to keep things up and running. And when we think about in the context of bringing that solution to market, we want to make sure that we're improving the quality of life and the environment at the same time as we deliver these solutions. So I always find it interesting and want to start off just with a definition, because we hear the words IoT and industrial IoT and what does it all mean. And very simply, when you think about IoT, it's about taking the physical world and connecting it up with the information technology world through sensors and connectivity, allowing us to monitor and control those devices. And there's really two primary use cases which separate what happens in the consumer world, which is really where IoT kind of took the foothold, and in the industrial world, industrial IoT. In the consumer world, it's all about convenience for the end user. And I'll give you the use case that I have. And for me, if anybody has a Nest thermostat or an Ecobee thermostat or something like that, and I know when I go on vacation, my wife always asks me, did you turn the air conditioner down? Is the heat down? Are we heating things? And I'm like, I don't know. But I can go to my phone and I could look at it and I say, yep, it is, or nope, it isn't. And I can adjust it. And it's very convenient. I don't have to go back after driving 10 miles out of town and say, did I do that? But when you start getting into industrial settings, it's not just about convenience. As Raj was saying, when you think about automation, what happens, it's about how do you create and provide business productivity. It's about connecting the devices and the machines that are on the floor with the information to run your operations efficiently and smoothly. And if you just think about that, being able to go and connect up to machines that are running and being able to understand if they're operating properly, being able to notify a technician or someone in charge and saying, look, this isn't running quite right. You may want to schedule and have your maintenance performed at a planned time as opposed to unplanned downtime, which you saw generates a lot of unproductivity for businesses. So when we think about the major trends that are out there affecting us, you know, in the next 25 years, 30 years, it's expected that over 2/3 of the world's population will be in an urban environment. And in that same time frame, electrical consumption will increase in the US by almost 40% just due to the proliferation of electric vehicles. When you think about now connecting that up, you know, in the next 5 years, there will be 10 devices connected to the internet for every person alive on the planet. And those devices will generate data that will compound by 40% year over year for the foreseeable future. So in short, really what's happening in the world around us, it's becoming more urban, more electrical, and more connected. And when you have to deliver solutions, you know, it's going to be a premium on making them safe and connected through technology. And safe is not just about making sure that it's safe from an explosion point of view, but safe from a cybersecurity point of view. So how will these trends affect an industrial environment? Let's just take a look at what's happened in one industry, like the electrical grid. There's really, with renewable energies coming on and more consumers of electricity, we're moving from a world that's unidirectional in electrical transmission to bidirectional. And that means that you're going to have communications. And that also means that it's going to be the intersection of IT technology and operational technology. And everybody's trying to get more productive. Everybody's trying to get more efficient. It's just more autonomous, more sustainable, doing things with less people. And this is really what's driving the future of a lot of industrial settings. So how big is the industrial Internet of Things? And it's coming. I mean, it's expected by some reports that there will be $6 trillion spent on these solutions over the next 5 years. And $1 trillion, that's a lot. I mean, I don't know how they come up with these numbers, but anyway, every report starts with a T, not a B. But what happens when you have to go and buy these solutions and you're the purchaser? Okay, so you start to say, okay, if everything's going to be more connected, what are my standards? Well, there's certainly safety standards that are in place, but what about cybersecurity standards? How do I know that if I buy solutions, every environment's heterogeneous generally in nature, how do I know that when I'm purchasing a solution from company X and I have to integrate it with company Y, that the same set of standards apply, that there's not going to be any kind of cybersecurity breaches or chances for vulnerabilities that occur between those different interfaces? And a lot of this, as I'll go into a little bit more, is really driven by there's a lot of standards out there, but there's a lack of coordinated global standards that allow you to purchase solutions and deploy them with confidence. So, you know, we hear a lot in the news about different cybersecurity breaches, and most of what we read is about informational technology. And the IT world is set up to basically put a fortress around the enterprise and protect the outside from coming in. And generally, two things happen when that breach occurs. You have a loss of privacy and personal type of information, or you have a loss of intellectual property that occurs. Now, they all are devastating in their own rights, but you read about it in the paper, but nothing really happens immediately. It may happen a month down the road. It may happen, you know, a year down the road. You don't see a necessary effect other than your data has been breached or your IP has been breached. That's not the case in the industrial world. If you look at some of these examples and take the one in the middle where a utility was attacked and they brought down a city block. I mean, the effects are immediate, the intent is very malicious, and there's very consequential results that happen immediately when that breach occurs. Furthermore, when you start thinking about from a manufacturer point of view or a producer of those products, we're starting to see where governments are now holding manufacturers liable for not putting the right amount of cybersecurity protections in place inside of those devices. It used to be, well, it was a process problem for the company that was deploying the solution, but now governments are starting to come after manufacturers and say, did you have the right level of process? Did you have the right level of testing? And do you adhere to standards? And is that baked into your solution? So I want to talk a little bit about some of the challenges, and I won't go through all of these, but I just wanted to point out the difference between the industrial settings when you're deploying a solution and the consumer settings. And one of those is how long a device is in existence. So your phone, how often do you upgrade your phone? Year, 2 years, 5 years? I mean, essentially they're disposable assets. New one comes out, I'm going to upgrade it, throw one away, and I go and I buy another one. When you're deploying industrial solutions, whether it be automation solutions or transformers, you expect these to last basically for the life of the building. You expect them to last 20 years, 30 years, 40 years. So it's impossible for any manufacturer to go and protect those assets for that amount of time because the sophistication of cybersecurity attacks continue to increase. But that's one of the challenges that we have to face when we're deploying solutions inside of an industrial environment. Let's take another one, and just the ability to upgrade. So, if you have a smartphone, you get a notification, say, you know what, I got a new version of the operating system, and we all come to effect, okay, I'm just going to go and I'm going to reboot my phone, and I'm going to download it, and it's going to come in and stuff. What would happen if you got a notice from your utility company and said, you know what, we're going to reboot the grid. Next hour, you're out of luck. Or you had to go to your spouse and you say, you know what, we got to reboot the house. I mean, it just doesn't happen. The availability and the expectation is that these systems are going to always be running, always be up, and it just poses a lot of challenges in order to maintain cybersecurity practices. And you take that on top of it and you say, you know what, it's not practical for companies to just go and purchase new equipment all the time. There's a legacy installed base, there's been capital appropriations for it, and it has to stay in existence and run. So there's a number of other challenges, but these are just a few of the things that you face when you're trying to protect assets in an industrial setting. So what are some of the things that we can do? I mean, it's not all bleak, but there are some things that we have to do as producers of products and as you purchasers of products to come in and think about. So it starts with kind of hardware, and you can go and you can get different types of processors that already have cybersecurity capabilities that are built into them and stuff, and put them into your devices. I think the other thing that we have to recognize is that there's going to have to be different business models put in place where companies are looking at how do you separate kind of the controls aspect from the physical asset that may be in a plant or maybe in a utility, and be able to upgrade those electronics periodically and do that on a regular basis so that you can stay cyber secure in your environment. Some of the other challenges, there's a lot of things that are connected. There's a lot of devices that are connected in factories, and there's also a lot that are not connected. So if you're going to have updates, and they're going to need to happen when you find security patches, when you find vulnerabilities. But can you do that over the air? Can you do it remotely? It's going to be almost impractical to send a technician out to go and plug into a device that's in a harsh hazardous environment or in a plant and do that all the time just to maintain the right security practices. So we're going to have to think about how do we do that in a safe way? How is the patches, how are they signed and communicated so that you have trusted assurance that the firmware is coming from a trusted source, and doing that over the air. I think the other piece that you need to keep in mind, and we all need to keep in mind, is just the proficiency around cybersecurity, especially in the operational technology space. Again, this is really new. Plant managers are not expected to be cybersecurity experts. IT typically does not get involved much inside of the plant, especially on endpoint devices. It's more around the information that's coming up. So we're going to have to look at how do you create that educational knowledge and institutional knowledge. So partnering with academia, partnering with institutions like CASE to be able to get the right talent out of school and bring them in and upskill your workforce is going to be critical. And really creating a level of proficiency and training inside of organizations is going to be vital. And one of the things that we've done at Eaton, we've taken this very seriously, and we've provided a base level of training on cybersecurity for every employee, regardless of function, just to be proficient. And, you know, we've heard a lot of feedback on that, and they say, well, I'm a mechanical engineer. Why do I need to know about cybersecurity? Okay, well, are you designing, maybe you're putting a communications port on that device? Yep. Okay, well, is it safe? Can somebody just come and plug into it? Do you know about how to protect that just from a mechanical aspect? And again, it's just things that you just kind of take for granted, but you need to be aware of, because not all security attacks occur over the air. I think another piece, we had a little transposition here on the fonts, but this is an area that's going to require a lot of work, and you need to keep in mind. Today, there is a lack of harmonized approach to cybersecurity standards. Okay, there's a number of standards that are different out there, and they overlapped. There's not a comprehensive standard that's available that covers everything. And a lot of these are being driven by different governments. They're being driven by different regions and stuff. And when you're a purchaser of product, how do you know what you're getting? If you're not familiar with these standards and know what part actually apply to you and know what a company actually certified against, you really don't know what you're getting. And then when you try to integrate these together, it's very confusing. So, you know, as an industry and with academia and with government sponsorship, we really need to come together and make it easy for the consumers of these products to be able to know what they're getting in very plain English, know how they integrate and stuff, so that there could be a consistency in the way that solutions are secured. So a couple things, and then I'll close up. I do believe that cybersecurity is a differentiator, and everybody needs to deploy and create a secure by design type of philosophy, and think about cybersecurity upfront when you're designing your products, not as an afterthought once they're already developed. Over time, cyber attacks have become more sophisticated and more autonomous. It's no longer someone just sitting down trying to hack into a device. It's very sophisticated, and these things are highly automated, and they're becoming more and more challenging to prevent over time. So you have to have enterprise-wide capabilities, you have to educate the people, you have to have the right tools in place, the processes, and create these platforms of knowledge, and making sure that the way you develop products is done in a consistent way so that people can buy it and know that it's going to be secure from day one. So a couple of things that, you know, we think need to happen to really create these standards. One is product and system level certifications. You know, I think just like you get a UL standard that's out there today and you know that has electrical safety, there needs to be standards that you know were verified by a third party that can say, yep, I know this product meets this level of cybersecurity and I could do it and it's trusted. I'm not just counting on word of mouth from someone, but somebody independently audited it and verified it. The other thing that we should think about is, are companies actually certified? Do they have the right processes involved to go and design secure products? And anybody can create a product that meets a standard, but you can do it consistently over time as the standards evolve. And making sure that companies have this process in place and it's verifiable and repeatable across many different product lines is going to be important to give that consumer the trust in the solutions that they buy. And then the last thing is you can certify a product, but as soon as you deploy it, all those certifications depend on how it's implemented in the field. And we have to look at these assessments to really go and make sure that it's secure once it's in practice. So, kind of concluding this, these solutions, industrial Internet of Things solutions, they're going to grow. Whether it's 5 trillion, it's a big number. I don't know if 5 trillion is right, but it is a big number. And it's going to be in the name of industries and businesses trying to continually lower their operating costs and increase productivity. So these solutions are going to continue to come out. Legacy infrastructure will not go away. So we're going to have solutions that deal with it and deal with it effectively and integrate these new technologies into that infrastructure. And this poses a lot of challenges for us. Unifying the regulations, unifying the standards, and getting third parties that can verify it is going to be needed to establish trust. And kind of the last piece, training and the new skills. I mean, every curriculum that's in college needs to have cybersecurity as a part of it, whether you're teaching electrical engineering, mechanical engineering, or computer science. This needs to be first and foremost, and we need to make sure that we're training our people inside of our businesses on these policies as well. From there? I'll turn it over.
Good morning, everybody. My name is Brandon Cornuke. I am the Vice President of Startup Services at Magnet. I'll tell you a little bit more about Magnet in a minute, but I just want to say that we were delighted to be invited to participate in this event today, partly because obviously this is a topic that matters to our economy broadly, all over our country and the world, but as Magnet, we're really excited to take this topic that means so much to our economic future and bring it down to a local level to tell you what it looks like in Northeast Ohio as we start to bring these things to life. So I'll tell you a little bit more about Magnet, and that'll help ground you in what we do. So Magnet helps manufacturers in Northeast Ohio. We've been doing this for 30 years. The intent is to help small and medium manufacturers get access to high-end resources that they might not otherwise be able to access and stay competitive and grow. We are supported primarily by the Manufacturing Extension Partner Network. That is a network of funding set up through the National Institute of Standards and Technology. This is essentially helping the nation at large compete in manufacturing. We're also supported in part, at least through my effort, by the Entrepreneurial Service Provider Network, or ESP, through the Third Frontier in Ohio. So there's a lot of resources there to all support manufacturers. And the way Magnet uses those resources in 3 primary ways. So one, we help connect our workforce to manufacturing by making sure that, to the best of our ability, the needs of the workforce are being met through our emerging students, right? Our primary or flagship program here is called Early College, Early Career. It's where we help connect students who are coming out of high school to jobs in industry in a European-style apprenticeship model, which we're really excited about. We also have a growth services area. This is our primary sort of 30-year history where we're helping manufacturers grow through all sorts of consulting efforts that includes engineering, strategy, marketing, and a lot of the primary consulting functions that you're familiar with. We also have a startup program that we call the Iterator. That's what I run. We help people turn physical product ideas into businesses. And we do all of this here, specifically in Northeast Ohio. So why does this matter? Why is manufacturing a big deal to us in our community? Well, we are really excited to say, and not surprisingly, I'm sure, that 45% of Northeast Ohio's economy is driven by manufacturing. What does that look like? So $72,000 a year is the average employee salary for someone in manufacturing. That's approximately $20,000 more than the average salary that you may find in Northeast Ohio. Every one manufacturing job here drives over 3.5 jobs in support of that effort, right? You make something, you got to export it, you got to support the people who are making it, and that turns into a lot of economic vitality. So manufacturing is super important in Northeast Ohio, and the topic we're discussing today is extremely important to that effort because, as you know, this term, Industry 4.0, we've heard there's a piece of it, IIoT as we're describing it. We've also called it smart factory. This is all connected to this manufacturing base, right, that we all rely so heavily on here in our community. That includes cybersecurity, as Michael's just discussed. There's cloud computing, big data, simulations, AR, VR in many cases, IIoT as one of the topics here, augmented reality, robotics, additive manufacturing or 3D printing in many cases, and systems integration. These are all topics that are sort of circling around this idea of taking our manufacturing base into the future. Now, what does that actually mean? If we were to quantify that and say, well, what does that mean for our economy? Well, McKinsey and one of our partners, the Team Neo organization, believes that it's worth $14 billion a year. Now, it doesn't have a T in front of it, but let me just remind you, or behind it, but let me just remind you that this is in Northeast Ohio right away per year. That's the economic gains that we could see by implementing these right away. These are not future technologies that we would be building into. Theoretically, this is what's available immediately today. What does that mean for us? And that is what it means. It's a big number. So there's a really cool opportunity here in Northeast Ohio, again, specifically because one of these aspects and aspects surrounding it, robotics, right, and all the wonderful things that come along with it in smart factory world, is very powerful right here. So if you look at this map, what this is basically saying is where people are deploying robots and where they are doing the most work are right here in our community. Surrounding areas as well, but we are sitting directly in the epicenter of a robotics revolution that is taking root in many cases inside our manufacturers today. Larger companies today are adopting technologies quicker than smaller companies. That's basically what this will tell you if you look. It's not adoption across the board, but if you look at the smaller numbers on this side, it's asking, just for one example, collaborative robots, are you adopting it? Smaller companies are not leaning into this as much as larger companies are, and for a number of reasons that we'll discuss. That's robotics. Let's talk about small and medium manufacturers adopting these emergent technologies broadly. So 3D printing, for example, something that's been around for quite a while if you ask folks who are familiar with 3D printing, but the newer, cheaper versions that are coming online that are really becoming accessible to our manufacturers and our economy are really starting to take root now. We're talking about really cool things like 3D printing of metals and ceramics and other things that are super useful. You can see that the adoption is tending up into the sort of quarter range. A quarter of manufacturers are adopting it by 2019, which is pretty good. But if you look at the rest of these technologies, these that we'll group into this Industry 4.0, they're kind of under 10%. There's two that are sort of eking just above that. That's smart or connected machines. And Raj mentioned a few of those. And then 12% are using sort of standard robots. Now, only 12% are using standard robots. Only 12% are connecting their machines at the most basic level. That means, is my machine up or down, and can I access that through a digital platform? So that's pretty incredible. So we've found, why is that? So there's a lot of reasons for that. We think in part it's that small manufacturers tend to need more help than larger ones, as you might mean, because they're worried about what's happening tomorrow or today on that factory floor. And these big concepts, Raj, you actually had a wonderful slide that had all of these terms, all right, there. It looked like 100 to me. That's what it feels like for a manufacturer to be asked, hey, are you connecting your machines? Are you IIoT enabled? In many cases, in our experience, manufacturer might say, what does IoT mean? and you may have to start the conversation there. In addition, that means that experience with those with ROI that really matters to them immediately isn't immediately accessible, and they don't necessarily always have a real good understanding of how to go from where they are today to where they can be tomorrow. So good examples. And then not necessarily having great access to a support system, a network of providers and experts, folks who can help them take that journey from, again, where they are today to where they are tomorrow. So this is how we're helping make these more accessible. We're enabling Industry 4.0 innovation, and I'm going to take you through a few stories about what to illustrate what that looks like. We are inspiring with experience and stories, and we're building a connected support system to support the digital transformation that we know our manufacturers are all going to have to take to stay competitive. So let's talk about a few of the stories. So this is really exciting. So let's start with the one in the upper left-hand corner. So Magnet was lucky enough to take part in the building of and directly support what is the largest 3D printer in the world in Youngstown, Ohio. So a company called Centric Technologies now makes is 3D printing what is essentially objects that are the size of cars. I have another picture in here. This one looks super cool and lit, but I would also show a picture of our entire team standing inside of this 3D printer. That's an example of 3D printing technology coming to Northeast Ohio and taking root. But what's really exciting about this is not just the scale of what you can do here. We're talking about things like printing cars and other sort of Department of Defense things that we can't discuss. But there's also an opportunity here, and the founder of Center Street Technologies is starting to think about how data matters in this and has built in technology that can actually learn how to print better, essentially using machine learning to teach itself how, when something goes wrong, it can actually improve itself over time, which is really exciting. So taking the scale of 3D printing and then turning it into something that is actually truly enabled by this factor, future factories or Industry 4.0 concept. Another example in the lower left is a company locally. They're a manufacturer. I can't talk specifically about what they do, but they're sort of in the food space. They came to Magnet and said, we want to change this process that we're using. We have this idea and we're not really sure what to do about it. And we showed them a bunch of technology that helped them understand what is possible from specifically collaborative robots point of view. So this graphic here kind of illustrates what that looks like. For those of you who don't know, a collaborative robot is a robot that will work side by side with a human being, amplifying their abilities. So rather than replacing them specifically, you can work side by side with these robots to augment what you do. And in many cases, these robots are safe to work around. They don't need a cage because if they bump into you, they'll stop and they won't hurt you. And that's the problem with working around robots generally. If you see the pictures of these car manufacturers with these robots that are kind of slamming into these metal things and sparks are flying, you don't want humans around those, but collaborative robots are an opportunity there. So we inspired them with that, and then that led to a combination of lots of technologies that all built, or that all coalesced into a brand new and patentable machine that has all sorts of wonderful IoT and connected ability in it that is now currently available and being worked on. And our engineers built that for our client, specifically around coming from inspiration from Factory 4 or Industry 4.0. You can see in the upper right-hand corner, this is actually a Case Western Reserve team, or at least they just were. They've recently graduated. They're working out of ThinkBox. Is Bob Sopko in the audience? I saw him earlier. He was helping. This is Boundary Labs. Boundary Labs is actually making what is essentially a very simple to install vibration detection mechanism that will teach you, or that will basically capture uptime, downtime for legacy old manufacturing machines. Tons of it here in town. You saw only 12% of folks are even IoT connected. They want to solve that problem by making it super accessible. So within a day or two, you can slap these things on there, get some data immediately, and then hopefully start learning about that technology to actually, to go to Roger's point, to start to lean into this idea of actually learning about those machines over time and predicting the maintenance you need versus having to kind of guess at it. And that's all to help bring the legacy manufacturing infrastructure into into the future of this of all these Industry 4.0 opportunities. And finally, the project in the lower right-hand corner, also a very exciting Case Western project. This was a team that developed welding robots that could weld any seam you presented it, even if it never seen the seam before. Okay, so why is this a big deal? This is a big deal because there are 50,000 open welding jobs in the United States, and these organizations desperately cannot fill them. This is using advanced visioning systems, machine learning, and robotics, all to help teach essentially how to teach that robot how to weld a seam that it had never seen before, which is really exciting. They just got a very big Series A round from an investment firm in Columbus, so we're really excited about them. So that's just some examples of some projects we've worked on. How we're enabling them is all through essentially the mechanisms that I described to you earlier, everything from the consulting aspects of our engineering through the strategy and guidance, connection to resources, as well as funders. So we're also inspiring through experiences, stories. So just like I'm telling you stories about some successes that we're starting to see here locally, it's also important for us to be able to take people locally and give them a hands-on view of what this actually looks like. So again, when you say Industry 4.0 and you show them these slides with all of these very sort of high-level words, what does it actually mean to bring that to a factory floor? Well, we have a factory here in town. It's actually on Cleveland State's campus, just down the tech corridor, where you can come and see a lot of these technologies that we've been talking about today in operation. And if you're a manufacturer, you could even toy around with them and see if they're useful for you and run some projects. This is an example of some visioning systems from Collaborative Robots. This is a picture of the laboratory floor as you walk through it with a more advanced CNC machine. The EDM cutting machine that you see in the middle can actually cut a human hair into 7 different pieces lengthwise if you need it to. So there's some very advanced stuff here. We actually have some augmented reality devices as well. It's really fun to come and play with the one in the lower right-hand corner. This is a visioning system that you don't need glasses to use, that will teach someone how to assemble a device that they've never seen before, essentially guiding them the entire way and knowing when and how you've put it together so that it can precisely tell you that you've done the right thing. These are accessible to manufacturers, and if you can come and be inspired by this, it makes it that much more likely that you'll start to lean into this future factory concept. And finally, we're building a connected sports system. So I will admit, Magnet's been doing this for a while, but when we talk about Industry 4.0 and what it means, it is going to take more than ever before a collective effort to bring this to life. It's not one organization solving the problem individually or an individual contributor or manufacturer. It's going to be all of us together helping people understand how this can really change our economy and our workforce. We do that through service providers. So we actually Magnet has a network of third-party providers that we are constantly cultivating to make sure that we're bringing the most talented and cutting-edge services to our clients. We also have an economic development organization network of partners that includes everybody from Jumpstart to the Burton D. Morgan Foundation and on and on. I'm going to leave a lot out, but there's this entire network of economic development organizations that we work with daily. We also connect with and partner with universities, community colleges here at Cleveland State. I happen to also be adjunct faculty at Weatherhead, and I work with ThinkBox all the time. I'm constantly on campus here and creating a more interconnected understanding of how those organizations, especially flagship research institutions like Cleveland State, can bring this to life is super important. We also bring in collaborating manufacturers. So we are actually sitting at the node of a collaborative manufacturing effort here in town that's just been started through the county and others that are bringing together manufacturers to address these sorts of problems, to raise their hands and say, this is what we need in terms of workforce, this is what we need in terms of support, and we are the convening entity there. Finally, we have all sorts of relationships with government agencies and labs, most notably NASA. So if we needed access to some of their technology and to help enable some of this tech, we could go to them as well as a number of others. So how am I doing? Okay, there you go. So that is Magnet in a nutshell, and how we're helping Northeast Ohio embrace this Industry 4.0 concept. Thanks, everybody.
I like how you said that you can cut a human hair 7 ways if you need it to.
It's just cool.
We're going to get a line of people out the door wanting to cut their hair into 7 pieces. So my name is Michael Treblecock. I'm with MCPC. It's actually a pretty exciting time at MCPC. There's a lot of changes going on there. I've talked with many of you in the room about how the company is transforming. One of those transformations is Community Innovation Partners, which we've recently announced, and really comprises a group of individuals at the company that are dedicated to what does the future look like. And to us, that means a few different things. What is the future of technology? What is the future of cybersecurity in our industry? But what is the future of the people that we're hiring and how we're elevating them through our organization? So I think I'm one of the only, or maybe the only one not in the manufacturing industry. So I have definitely my lens on things, and everyone at MCPC, the lens is it's cybersecurity. And the water cooler talk is about patching and antivirus and all of these really sexy topics that, as you can imagine. So I think before I came to MCPC, one of the earliest experiences I ever had with the topic of IoT, which happens to be most relevant to our business today, dealing with endpoint devices. I was a rower in college. So I was out at the University of Washington, but we showed up to practice one afternoon, and it's if you've ever seen one of these boats, I know Case has a good team here. If you've ever seen one of these boats, they're almost the length of this room. They're about 55 feet long and about 2 feet wide, so they're almost narrower than your body is. But so we showed up to practice one day, and they had one of these vessels rigged with wires and sensors, and it was measuring everything from the pressure that you were putting on your foot to the bend of the oar to the rowing it's leverage. You're sticking an oar in the water and leveraging it against the boat. So measuring the kind of the force curve through the stroke. So it was about 150 different measurements that this technology was pulling off a boat, and it's one of the oldest Olympic sports out there. Like, technology hasn't really been embraced entirely by the sport. So it was one of the earliest experiences I had with IoT, but it was so interesting because it was, what does that mean in terms of how the sport advanced? And there's, a sport that's been around for hundreds and hundreds of years. Now, some of these finishes at a world championship, for example, it's the closest they've ever been. You think of rowers, you think of the 6'7" giants out there. There's guys now that, because of all this data that they've extracted from the way they're training and the way that they're tuning their boats and their oars and their equipment, there's guys that are 5'10", 6 foot, even kind of average size, that are winning world championships and setting world records even. So it's pretty fascinating what you can do with data when it's applied. And so that's kind of, I guess, if we had a topic, I think, where technology meets people, meets process, you were talking about, Raj, earlier, that's important to us at MCPC and a lot of what we're thinking about. So we kind of focus around, in terms of MCPC specifically, around this idea of security certainty. And when you think about cybersecurity, there's a lot of expertise in the room around technology. You don't think of certainty ever. So this is definitely a goal. This is also in some ways an invitation for bad actors in a lot of ways. So it's quite a statement to come out and say security certainty, but we believe it, and we trust in the processes that we've developed at MCPC. We trust in the people that we have running them. So we're confident that when our model is applied, that it's truly setting an organization up for success and to enable their future. And inherently that means all of the new technologies that they will be adopting. So I think something I wrote down here, you don't know what you don't know, which is definitely a parallel to technology and cybersecurity, absolutely. You can't measure what you can't see. So I talk about rowing, or you can talk about anything, a manufacturing process, and you can't secure what's already gone. So cybersecurity is not it's not a reactive type of industry. Everything has to be proactive. So there's no offense is your best defense kind of in our industry. So kind of going into a bit more detail about what MCPC does. This is what we'd sort of consider our quiver of resources. This is how we approach every organization. This is how we think every organization should approach technology. It's complicated. Technology is complicated. So we've put together resources that range from advisory resources to some of our technical solutions that really the aim is to provide, again, this certainty, but also doing that via solutions that wrap holistically around a technology environment, so that we're not just an antivirus reseller. We're not just recycling devices. We really comprise the entire life cycle of an endpoint device. So oftentimes I heard this recently at another conference, this idea of carpeted environments versus non-carpeted environments. And all the industry 4.0 people in the room will understand non-carpeted environments. That's the manufacturing floor and where things are getting done and things are getting made. Carpeted environments is where we've lived since the inception of MCPC. It's your laptops, it's your phones and tablets and desktops, if anyone still has a desktop in here. So that transition point is really where this new division of ours, Community Innovation Partners, that's where we're trying to live, is what are the adjustments we have to make with this process to be able to go into those types of environments. And for us, that means a lot of new partnerships. Like I said, when I started, we're not manufacturers, but we serve manufacturers. We're not a bank, but we serve a lot of banks, and we're not a hospital, but we serve hospitals every day. So how do we put together that type of expertise that allows us to go into those environments and not just service their IT teams, but to service really how they're using technology and leveraging it to drive better business outcomes. So that's been an ongoing development for us. So kind of, I'll ask by a show of hands, has anybody been involved in a project that involved data? Yeah, okay, good. Just trying to get you to raise your hand. But I mean, it's everywhere, and the projects are seemingly really simple at the surface level, but when you dig into it, it's wildly complicated. So I think the best example I could think of is at MCPC, we, like I said, we serve a lot of different clients in a lot of different industries. So, healthcare as an example, a lot of hospitals that we're servicing, and in very similar ways, as you can imagine. But definitely we're not going to walk into Hospital X and say, we did this with Hospital Y the other day and it worked really well, or this didn't work really well and they were breached or something like that. So we're often asked to do kind of like peer reviews or sort of benchmarking. Where do they fall on the spectrum? Pretty simple. We have a lot of very smart consultants, so we're able to do it. But something that we're in the process of developing is, well, what if we could develop almost a tool that would allow us to articulate where companies fell in their peer group, so that it was almost an automated type of process. Pretty simple. It was all data we already had. It didn't mean we had to go kind of develop new data or extract different data. It was all stuff we had in our systems, or it all is stuff we have in our systems. And it was just a kind of a process of how do we rearrange this and restructure it in a way that's visual, but also interconnected and interoperable. That word was thrown around, so that our systems can talk to each other, and that the information that comes out at the end is usable by the end customers. Because very often, so much data out there, and I've all been involved in these types of projects where data comes out and or an IoT project is implemented, and one of the goals is we want the data out of this process, or we want the data out of this new product, or what have you. And doesn't mean it's usable, doesn't mean it's useful. So really the point solutions are everywhere, and these types of projects are going on in every organization. But it's truly a matter of, if they're going to be productive and add value to you as an organization, they need to add value to your products or to your customers or to the customer experience. They really need to be contributing factors, not just luxury factors. So I guess this idea around governance comes up a lot at MCPC, which is, again, one of those water cooler conversations that happens there, and I'm sure happens in a lot of places now because technology is everywhere. But this whole idea around the creation, the storage, the use, and then the deletion of data, and how is that accomplished? And it seems simple. Well, we just keep it in one place and keep track of it. But when that one place turns into an organization with 100,000 employees, it's all of a sudden your data is on someone's device all over the world, or pieces of it, fractions of it. So to us, kind of this idea of governance is really what our chain of custody process is built on, that I talked about earlier, is how do we manage kind of that life cycle, but kind of put the tools in place so an organization can keep track of who has what. Are they authorized to have access there? Should they connect to this network? Are they traveling and they need a kind of a blank device to travel with, so they're not taking corporate information overseas or what have you? So I guess a hospital we worked with several years ago, so the technology was older, but kind of this process was implemented in a very similar fashion. The hospital wanted to prescribe in-home physical therapy to some patients. So they'd go through surgery, knee surgery, they need to do certain exercises every day. Great. So we worked with them to develop a solution that was a screen and a camera, could monitor the exercises remotely, and then the doctor could review them on their own time. It's so something that would normally require a visit to a physical therapist, and an appointment that would often get missed or rescheduled. So a lot of overhead involved, but something that would often involve going to a hospital can now be done in your home. So MCPC's part in it was to pull together, I think there were 24 different components to this unit that was packaged in a pretty large Pelican case, and it was deployed by MCPC. So an MCPC truck would show up at the home, get the device set up. It was as easy as opening the box, pushing it on a button, and it would start the process. And then once the exercises were done, we'd take the device back, or if it was there for maybe they needed it a week or a month or whatever, we'd take the device back. We'd run it through a decontamination process. So if there were any like bed bugs or lice or God knows what on these devices, then we'd clean them and then put them back into use. So I think ultimately we had only 12 of these devices, but they serviced hundreds of different patients because they were recirculated through the process. But it seems like a very logistical kind of feat that we're solving for, which a lot of it is. But ultimately that the auditability of that logistics chain, and being acutely aware of keeping track of who has what and why they have it, and all of that information is kind of integral to this idea around governance and what that means. So kind of in that scenario, we were a subcontractor for this hospital. So I think all these, there's a couple of focus areas that are really commonplace when you think about the future of technology. And compliance and regulation, a huge one, governance, and then data protection. So this is kind of a fascinating statistic that 70% of companies are really unaware of the protocols or regulations that their subcontractors are holding themselves to. So as kind of a lot of this technology feat gets outsourced even, or other services that you're consuming that maybe you're unaware how they're using your data, oftentimes it's only the best and kind of most aware organizations that are truly focusing in on this fact. And you talk about HIPAA and GDPR and all of these sort of data regulations that have come up in recent years. It's critical to the future of this and really to the future of organizations that they're paying attention to and being not only extremely aware of all these things, but they're putting the pieces in place. And so that's really what MCPC tries to get our customers to accomplish is all these pieces need to be in place, but that doesn't necessarily guarantee anything. But it's the best of breed of what we can do today with the technology that we have kind of in our reach today. This is a point that I'm very passionate about when technology meets the living world. So when people meet technology, kind of over the years as sort of human beings, we're always developing tools. We're creating like a spear out of a tree branch or a shovel out of metal and a handle. And technology really hasn't been any different, at least digital technology. It's a set of tools and it's highly configurable. And it's really exploding. So I talk about like a slow explosion, really all this buzz around IoT, around data, around even cybersecurity. It doesn't all hit at once. And it's something that it's not that it's not coming. It's not that it's not here. We talk about all the time. We're talking about the trillions of dollars that are going to be spent on IoT or IIoT or cybersecurity over the next 10 years or so. And it is really a slow explosion of this stuff. And there is time to get in front of it. So that's where MCPC kind of sees ourselves fitting is can we get in front of all of this and get those pieces in place so that organizations are prepared for it. And when they do adopt new technologies, or when they do grow their fleets of devices, on average, every employee now has 6 corporate devices to their name. So what does that number look like in even a year from now or 2 years from now? So when these fleets are doubling or quadrupling, do they have the pieces in place to manage it? So disruption is also another buzzword thrown around a lot. And I think the kind of this idea that disruption doesn't have to be super high tech. Disruption can be pretty low level. I think MCPC as an example again, go back 10 years and MCPC was a reseller. We were buying hardware from HP or a distributor or Apple or Lenovo, and we were kind of configuring it how the customer wanted it, marking it up, and pushing it back out the door. That's it. That's how the business grew for about 25 years. And so disruption in that scenario was cybersecurity. And what did that mean? We knew it meant a lot to our customers we were serving, but it didn't necessarily mean a lot to us. So about 5 years ago was really when we started transforming our business into now a managed security services organization where we're truly an integral part in a cybersecurity strategy for our customers. So no longer just buying and reselling, but providing a comprehensive solution that's enabling a lot of change and a lot of technology growth. I think another piece that is often underlooked is where human capital comes into the equation, and so kind of this idea where MCPC is not just a technology company. We went from just selling or reselling devices to now we're providing services, and all of those services are driven by the people that we have at our company. So investing in the right talent that can grow the company, but also provide a good customer experience. So we've partnered with Mercyhurst University and also the Cleveland Metropolitan School District. So we're attacking it from really those two angles. Mercyhurst has one of the highest level intelligence programs in the country, and we're kind of sourcing a lot of our higher degree cybersecurity talent from there. And then CMSD is we're out on Euclid Avenue, close to schools out there, and then we're down in Old Brooklyn, close to several schools there. We also operate a School of One program, which is like a virtual hybrid school, but we're bringing those students in and teaching them the lower level, entry level roles, and then creating pathways within MCPC where they can grow their careers there, hopefully. So kind of the last point I wanted to talk about was, what does this mean in terms of kind of the future of technology, the future of all of these industries, but the future of just companies in general and how they're investing in their people and investing in new technologies. So we've developed a lot of new partnerships when it comes to either state and federal dollars, foundations, even venture firms and private equity firms around what is the right mix of all of these types of partners that allows us to invest in people, technology, process, and new ideas in a way that is enabling a future and isn't teeing ourselves up for a lot of risk. So I think that's all I have to say. Thank you.